All right, today we're going to talk about lesson 83. We're going to take roots and write quadratic functions, or write an equation for a quadratic function. So an example, we need to write a quadratic equation when we know our roots are -3 and 5. Well, we want to work backwards because in the past, this is what we've been working towards, is finding our roots. And now we have our roots and we want to work backwards to find the function itself. So we need to set up our parentheses because one of the ways that we can solve a quadratic is by factoring. So when we're given our roots, probably the easiest way to find the actual equation is to work backwards as if we had factored. So inside our parentheses, remember our sign will always be opposite of what our root was. So our root was -3. That means our parentheses is going to say x plus 3. Likewise, when our root is 5, our parentheses is going to say x minus 5. We need to write our quadratic equation in standard form, so we need to take these two binomials and FOIL them. When you do that, you get that, and you can simplify your middle two terms to get x squared minus 2x minus 15 equals 0. So this is a quadratic equation with the roots -3 and +5. Okay, I would like you guys to write a quadratic equation with the roots 2 and -7. We're going to look at another type of problem. We're going to write 3 quadratic equations with the roots -4 and -1. So our first step is going to be the same. We need to start with our two sets of parentheses. So we have x plus 4 and x plus 1. When we FOIL that, that becomes x squared plus 5x plus 4 equal to 0. And now that's one of our quadratic equations. We need to still write 2 more. So when it comes to your multiple equations, you can do a variety of things. So we're going to multiply by some constant. It could be a 2, could be a 5, could be a -1, could be a -3. Something that's going to change this function but still give us the same roots. So I went ahead and multiplied by 2 first. You need to multiply everything by 2. So distribute that all the way through, and you get a 2x squared plus 10x plus 8 equals to 0, or equal to 0. Then, like I said, you can pick any other number. I chose a -5. So again, when you distribute that through, you get this third equation. So in the boxes, I have 3 different quadratic equations. If you were to factor them, you would still get -4 and -1 as your roots. Okay, something a little different. We're going to write an equation for a quadratic function. They only tell us one root. Well, we've solved problems like this before. We call that root a double root. Since it's still quadratic, we know we need it to be or have a degree of 2. So we're going to write our equation like x minus 6 squared. Remember, in order to write that in standard form, you actually have to FOIL, because x minus 6 squared looks like that. When you FOIL, you get x squared minus 12x plus 36 equal to 0. Okay, one more example. We're going to write a quadratic equation. This time we're going to have a complex, 2 complex roots. So we have 3 plus 2i and 3 minus 2i. When we solve, when we get our solution, we've always had x equal something. So we're going to start this sort of a problem by setting x equal to our 2 roots. So x equals 3 plus or minus 2i. Now we're going to kind of work backwards. So in order to get this 3 plus 2i, we would have moved this 3 from the other side. So we're going to actually move that 3 back to the other side by subtracting, giving you an x minus 3 equal to plus or minus 2i. And we know that plus or minus 2i is the solution to the square root of -4. So we can rewrite it to look like that. And now we have this square root that we want to get rid of. So to get rid of a square root, the opposite or the inverse operation would be to square both sides. So we square both sides. Well, on the left side, we have to FOIL, and on the right side, the square root and the square cancel. So on the left side, we're going to have x squared minus 6x plus 9 equal to -4. And our last step would just be to add that 4 to the left side, leaving you x squared minus 6x plus 13. So the last thing I would like you to do is to write a quadratic function with the roots 3i and negative 3i.